Very good morning to all. So, welcome to today's lecture. We will continue with machine tool gearbox. So far, we have done a regular structural formula gearbox aspect. There, we have done a ray diagram as well as a kinematic diagram, and also we have discussed the number of teeth of each gear in the gearbox aspect. So, today's lecture, so we are going to learn about for non-standard machine tool gearbox. When you say non-standard machine tool gearbox, that structural formula may not fit, right? If you have out speed like 14 speed, right, it won't fit into either 12 speed or 18 speed. So in that case, how are we going to do the problem? Okay, that's how we are going to learn about non-standard machine tool gearbox. So the problem is here. We are going to do the second problem. A machine tool gearbox powered by 11 kilowatt 970 rpm motor is to give 14 spindle speed ranging from 20 to 400 rpm. Draw the ray diagram. Okay, I am restricted to only the ray diagram. Supposed to do kinematic diagram also, but our focus, if you understand the ray diagram, automatically you can able to do the kinematic diagram. Okay, that's how I am covering the various aspects of machine tool gearbox. Please note down the problem. So you have a 14 spindle speed a gearbox, right, ranging from 20 to 400 rpm. So that's what is given. No other information. We don't know what is the step ratio, which series is following. All those information not given. Okay, but we know that Nmax coming as a 400 rpm. Your N minimum is the lowest one, 20 rpm. Okay, the number of speeds are 14. Number of speeds are 14. Okay, let's find out what will be the step ratio. I'm sure you know this formula 5, right? N max, N minimum equal to power of N minus 1, where your N equal to 14. So if you substitute, okay, your 400 divided by 200, okay, and substitute N equal thing, then step ratio you would expect to get 1.259. This is step ratio. Substitute N equal to 14 and do that, right? And do you know, is a 5 equal to 1.29? Approximately we can make it as a 1.25. When you do that, 5, this step ratio is belong to R10 series. R10 series. You can refer the table which I have already shared, and also it's there in the data sheets. If you refer it, right, you can see R5, R10, R20 and R40. So our case is 1.25, right, we got. So of course we got 1.259, we approximate as a 1.25. As you are aware of that, the psi ratio 10% can have a variation. So in that way this is fine. Okay, then how are we going to use this? Select the speed. Two way you can approach, either using this preferred number table, otherwise the other formula you have. I'll explain what is that. So how are we going to start? What is the minimum speed do we have here? 20 rpm is the minimum speed and 400 is the maximum speed. Okay, so this is, can we say it's matching exactly? Even though the 2, if you multiply by 10, it will be 20, right? So right, 20, then we can say 25, right? 31.5, 40, 50, 63, 80, 100. Okay. So, it's over. What will you do now? It is cyclic. You can again come back to the front, right, because of this is 100, right. So, this will be again 100. So, the next one will be 125, 160, 200, 315 and finally 400. This using the table you can find out in this direction, in this method. You can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 14. Okay. So, what is the other way to do that? Where is the other way? Any idea? I can give you a clue. Remember n max, n minimum, right? That is power of psi power of n minus 1. With that you can do that. With that, that's also you can do that. For example, suppose if I want to have a n, I'll give you n4. If you want to have n4, what is that I should have that formula? Yeah. Your n1, right? n1 psi power of 3 times, right? Because of that's a thing. So, n1 would be 20 rpm. Okay, this should be 1.25 power of 3. Can you tell me what is the speed you would expect here? 40. Am I right? Yeah, should be 40. So, we n4, check it here, check it out here. This is the fourth speed n4, right, which are 40 rpm. Here also 40 rpm. So, in this way also you can do that both ways, because of, anyway it is all based on the your n max, n minimum, right. That is a formula of psi power n minus 1. This is the one. So, if you keep, if you want to n5 power of 4, n6 power of 5, like that you can do that. So, two way you can find out this speed if not given in the problem. I think it is clear to you now, right. Now, I know that, so 14 speeds are there. So, how about the ray diagram? Do you, how are we going to do that ray diagram? The preferred formula is given what? The preferred formula is given as a what? 3 of 1, right, 3 of 1, anything else? 3 of 3, 3 of 3, then it should be 2 of something. What is that? Before do that, we are going to use 18 speed structure, right. So, you have a 3 and 2, 3 into 3 into 2, 18 speed, okay, but we have only 14 speed. So, we can't have a 18 speed thing, but we are forcing to use the 18 speeds to avoid that confusion. So, right, this is the 6 times, right, it will be 9 times, 9 minus 5, so 9 minus 4, I am sorry, beg your pardon, 9 minus 4 would expect 5, because I am subtracting 4 speed from the output. 18 speed supposed to be for 18 speed as a output speed in the gearbox. From there I am subtracting 4 speed, so that I would have a 14 speed. So, that should give me 14 speed. Okay, we will see how it is going to give 14 speed. So, the structural formula now 3 of 1, 3 of 3 and 2 of 5. Okay, 3 of 1, 3 of 3 and 2 of 5. You can see here. So, constructed, and you know this is your first stage, and this is your second stage, and this is your third stage. This should be 3 of 1, 3 of 3 and 2 of 5. Okay. So, minimum speed is 40 rpm, it is clearly given, and the maximum is 400 rpm, and also motor speed is given to you, right, motor speed is given to you, As we did in the earlier, right, the previous problem 18 speed, similar way we are going to follow the procedure. So I know the speed is given for stage 3 will be 20 rpm, that's a one. The next would be what? Look at the formula, 2 of 5, that means 5 steps away. Okay, so 1 2 3 4 5, so there will be this one. We will start from the bottom and fill the speeds stage by stage. That's the procedure we are going to follow. Of course, you need to follow again the same formula, I max, I minimum. Because of the optimizing, we can't have a more than the ratio 8. Okay, so this is the one. So we will go for this stage 3 now. Right, this is the stage 3. As for the stage 3, already I have discussed, your speed is 20 is the minimum speed, maximum speed is 63. Now we need to find out what would be the input speed for the stage 3. Okay, so it cannot below 20, it has to be above 20, right, and between 20 and 63. Okay, so we will choose as the input speed n input as a 63 rpm. Okay, input as a 63 rpm. So obviously we n max, n minimum. Okay, sorry, it should be n input, n input 63 and we are taking 63 equal to 1, which is less than 2, satisfying. Okay, that's one thing. The second thing is n minimum, n input, the n minimum is your 20 rpm, input is 63 rpm. If you do that, you will get 0.317, which is greater than 1 by 4. So it is satisfying. Okay, this is satisfying. So can we choose 63? What do you say? Maybe we will try 60, next input speed 50 also, and see what is happening. Okay. So the second case, earlier case 1 we have chosen as a input speed 63 rpm. Now let use as a 50 as a input speed. Let use n input 50 rpm. Okay. Yeah. Again, please repeat the thing, n max, n input, n max 63, input 50 rpm. So that should give you 1.26, which is less than 2. Okay, it's fine. Then n minimum, n input, minimum is 20, input is 50, that's give me 0.4, still greater than 1.4. Okay. So you may ask question, if I choose 63 rpm, it's satisfying both condition for I max, I minimum. If I choose 50 rpm, also satisfying I max and I minimum. So which condition are we going to use it? Both are possible. Okay, both are possible. So however, as I said, we want to have a maximum reduction, so better we choose n input as 63 rpm. Okay, in the both condition we choose select n input as a 63 rpm, though both conditions satisfied. So that the flexibility is given, right, that flexibility is given. Now stage 3 is over. Stage 3 formula what? 3 of 1, right, 3 of 1. I'm sorry, this should be stage 3, right? 3 of 1, 3 of 3, 2 of 5. This is what supposed to be. This is the formula. Okay. Now, so we got it now. We got it. we are moving to the stage 2. Before going to stage 2, we need to finish the stage 3, right? What is the stage 3 formula? We have already mentioned that 3 of 5, okay. Sorry, okay, sorry. Thank you, 2 of 5, right? 2 of 5. So, one input speed we got it. What is the next input speed would be? Where would be next input speed of stage 3? Yeah. See, see, these are the input speed, right? These are the input speed. Each input speed will give you 2 output speed. That we got it. So, where are the other input speed? That's what my question. We need to have another 4 input speed, right? So, how are we going to do that? What are the possible input speed of stage 3? Yes, but already you have indication also, that there is an indication also given. 2 is given indication. One input speed should give me 2 output speed apart 5. That is given, okay. Now the question is, in stage 2, when I go that, how many input speed I need and how many output speed do I need? That's the question. Yeah. Again I rewrite 3 of 1, 3 of 3, right? Then 2 of 5. Okay, this is what given. So how are you going to proceed now? Yeah. You have 125, you have 250 RPM, right? This is clearly given, 250 RPM. So 125 is there, 250 is there, and 63 you have. So that means your N max is 250 RPM, your N minimum is 63 RPM. So the N input should be between 63 and 250 RPM. Okay, right? So we'll choose as a 250 RPM an input speed. Okay, we'll choose input as a 250 RPM. Right. Again, we'll try this I max, N max, N input 250. That is 1 is the less than 2. Fine. Your N minimum, N input, okay, is 63, right? 63 by 250. I am getting 0.252 is greater than 1/4. So that's also correct. Yeah, that's also correct. So both are satisfying. Now, okay, now we'll this is over now. Okay. So now we'll you have a 3, okay, 3 output speed you have, 3 output speed I have, but you need to have how many input speed of stage 3, sorry, stage 2, 3, right? Look at the formula, this is 3 output, right, 3 input speed, and each input speed will give me 3 output speed, okay. And the possible way is you can have 315 and 400. That's what you need to have it. Okay, that is it. Now stage 1, the stage 1 formula is you will have a 1 input and 3 output. Okay, 1 input and 3 output. So obviously this I max and I minimum won't follow in the first stage. You can choose whichever, but I'll choose straight away my input speed as a 400 RPM. This is what happened. Okay, you can see now. Yeah, so I've arrived at the first the ray diagram aspect, and if you look at, right, I can name them A, B, C, D, E, F, G, H and I. For our own convenience, we can have these things. Yeah. So now we have things. Okay. So let's try to connect them. When you connect the one input speed, you will have a 3 output speed. Okay, of 3 of 1 and 3 of 3 and 2 of 5. Okay, we will see that. That should give me 3 output speed. Okay, I to F, F will give me, right, again 3 things, right. From F we will have a 3 output speeds. You can see that E, F, sorry, E, D, C is satisfied. Okay, for one input speed of stage 2 gives me 3 output speed, which we have already. The next, this again will give me 2 output speed of stage 3. The C would give me 2 output speed, which is apart 5 step ratio, which clearly given. Okay, it's clearly given. Now we have, yeah, it's done. Now we'll move on to the next thing, which is G. Remember, apart from first stage, everything you have to follow the parallel, either vertical way or side way. As long as you parallelly maintain, that means you are maintaining the step ratio across all the stages. That already we know that, and you should aware of that. The step ratio in y-axis in logarithmic scale. Okay, it's in log, but our convenient we have make it as a linear diagram. It for our convenient, for understanding purpose, right. So now from you can see that you have a 3 outputs from one input in stage 1, right. Now within the stage 2 we are making progress for developing the ray diagram to other stages, right. Now you can see that from F, right. So the D will have a 2 inputs. Okay, D for as a input will have 2 outputs. Similarly, E will have a 2 outputs, and both are placing 5 step ratio apart, 1, 2, 3, 4, 5. Similarly, for D you can see that 1, 2, 3, 4, 5, so on. So, but that is complete. Okay, we finished F leg. Now move on to the G leg, right. We will make a different color. Again G, how many speed you expect? Output speed for G in stage 2, 3 of 1, right, 3 of 1, 3 of 3 and 2 of 5. This is what happened. Okay. So you have a 3 step away another output, and there should be one more output. Look at this. This output should be parallel to the F output. You can see that these two are parallel. Yeah, that you can see that. Similarly, from G point, right, this blue color is parallel to the F ray in this thing. Okay. Again, the third output from G should be parallel to third output of F. You can see here the blue line as well as the red line. They are very parallel. They are very parallel. Again, this one will have a 2 output. This will be 2 output, and this will be 2 output, and this will be 2 output. Right. Let us see. So that again extending 2 output speed from here to here, and again we have 2 output speed here. Then this one output speed, and this should give me another output speed. Again they have 5 speed step ratio apart from here to here. Look at this, 1, 2, 3, 4, 5. Same way this one parallel to here with maintaining 2 step ratio. Then we will have the line which is parallel to here. So always whatever we followed in stage 2, the same thing we are following in stage 3 as well. Okay. Now the final thing is another output speed in G, right. G is over, now H is there. From H we will have a 3. You can see that this line and this line is parallel. Okay. then you will have this purple line and this one is parallel, then this purple line and this one is parallel. So now you have three parallel lines, you can see that, okay, from H, G and F, each will have three lines. If you extend it, you can see that now you can see that, right? Maybe I can see that. So now we filled all those things. So what is your observation here? What is your observation? There are 4 intersections which never happen in the regular gearbox. What are the intersection? 125 one intersection, 100 another intersection, 80 another intersection and 63, you can see that. So you can see that the speeds, right, 4 speeds, 63, 80, 100 and 125, right, are overlap speeds. It's called overlap speeds. Overlapping. They are not individual, right? They are not overlapping speeds. We can see that overlapping speeds. They are very, you can see maybe in this picture you can see very clearly this 125, as I mentioned, 125 here, 100, 80 and 63 are given overlap speeds. Okay. So there is a possibility, right? Right, we can have a 2 different diagram for assuming that, right, you can have as a one thing is A, B, C, D, you can see that A, B, C, D, that is one way you can do that. What is the other possible way from if you using as a 125 RPM? There are 2 different routes, isn't it? Yeah, look at this. This is the one route, you can see that from here to one route. Otherwise, what is the other possible route? From here. So you can see 2 different set of things, right? Yeah, that is the reason this 63, 80, 100, 125, right, 120 RPM speeds are called, again I am emphasizing overlapping speeds, because they are overlapping with the regular speeds. Okay. So is it clear now how to do a non-regular gearbox? It's very clear, right? What is happening? So now do you understand? See, the 18 speed supposed to be 3 of 1, 3 of 3, right, and 2 of 9. This is the regular, am I right? This should be regular one. Okay. What we have did, we have done 3 of 1, 3 of 3 and 2 of 9 minus 5, I am sorry, 9 minus 4, we deducted 4 and we got 5 and use as a 5 input speed to stage 3, right. So this is a non-regular or non-structural gearbox. Hope it is clear to you the difference between the regular as well as non-regular. Okay. And look at this, in non-regular there is always overlapping speed, you can see the cross is happening. At the moment you look at here, do you see any crossover? No. So that is the indication. The moment you see the diagram, the ray diagram, from the ray diagram itself we can able to tell whether it is a regular structural gearbox or non-regular structural. Both way you can do, you can identify that. Okay, you can, by that is the difference. There won't be any overlapping in the regular gearbox. And this is the non-regular. You can see the overlapping. And this is I have given another additional 3 problem for you to do the homework. And also I will give a separate assignment for machine tool gearbox. Okay. In fact, whatever we discussed in the so far last 6 lectures, I have referred these 2 books. N.K. Mehta, Machine Tool Design and Numerical Control. This one book. Other one is P.H. Joshi, Machine Tools Handbook Design and Operation. Both are excellent books. It will give you more information about the machine tool gearbox. Okay. Our aim is we want to study about the gearbox. Okay. This gives you a fair idea of the ray diagram, kinematic diagram aspect. The moment we go for automobile gearbox, we will take this information, construct the ray diagram and kinematic diagram for automobile gearbox. From there, we will go for design calculation. So far, we have not done the design calculation. We have discussed above the ray diagram, kinematic diagram. The reason for this, your machine tool gearbox has so many different speeds. Start from 6 speed, 8 speed, 12 speed, 15, 18, 24, so on. Whereas your automobile gearbox is limited to 7+1, right. So, you may not understand the complete information. Okay. So, with this understanding of ray diagram and kinematic diagram, we are moving to automobile gearbox in next class. Yeah. Thank you.